Today we're going to continue on our work with graphing equations in quadratic equations in standard form. And just as a reminder, standard form looks like y equals ax squared plus bx plus c. But today we're going to do the more challenging equations. And these are the ones that can't be factored to find the x-intercepts. So we're going to have to use the quadratic formula today. So we're still going to follow the same steps we've been doing all week. So that's not changing, which is nice. Step 1, find the vertex. So to find the x value of the vertex, we're going to use x equals negative b over 2a. And then we're just going to plug that back into the original equation. I'm just going to remind myself a in this equation is negative 1, b is 2, c is 1. So x is equal to the negative of 2 over 2 times negative 1. So x is equal to negative 2 over negative 2, which is simply 1. So my vertex has an x value of 1, and then a y value of y is equal to the negative of 1 squared plus 2 times 1 plus 1. So I just took 1 and I plugged it back in for x into the original equation. Y is equal to negative 1 plus 2 plus 1, so y is equal to 2. My vertex should be at 1, 2. The axis of symmetry is just x equals whatever the x value of my vertex was, so x equals 1. Now to find our x-intercepts. So y is equal to negative x squared plus 2x plus 1. To find an x-intercept, we want to make sure that y is 0. And then this is not going to be factorable. So we are going to want to use the quadratic formula. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So x is equal to negative 2 plus or minus the square root of 4 plus 4 all over negative 2. So x is equal to negative 2 plus or minus the square root of 8 all over negative 2. So off to the side, I'm going to simplify the square root of 8. So the square root of 8 is really 4 times 2. The square root of 4 is 2, so I can bring that out front. So root 8 simplifies to 2 root 2. So this is x equals negative 2 plus or minus 2 root 2 all over negative 2. So we're going to have x is equal to, because, let's see, we talked about simplifying these kinds of fractions before, where we have to simplify this and this. So negative 2 divided by negative 2 is 1. Plus or minus, and then 2 divided by 2 is 1 root 2. So this is really just x equals 1 plus or minus root 2. But how the heck do we graph x equals 1 plus or minus root 2? Well, these are two separate values. X equals 1 plus root 2 and x equals 1 minus root 2. So let's use our calculator to help us figure out what these values are. Square root of 2 plus 1 is x equals 2.4. And then the square root, the negative root 2, 1 minus root 2, is going to be, let's see, 1 minus the square root of 2 is negative 0.4. And we're just going to round those because we can't graph 1 plus root 2, and we can't graph 1 minus root 2, right? So we have to use the decimal form of those since we don't really know where 1 plus root 2 is on a number line. So we're going to have an x-intercept at 2.40 and negative 0.40. Now find the y-intercept. So the y-intercept is easy to find. We just plug in 0 for y. Or for x, sorry. So y is equal to negative 0 squared plus 2 times 0 plus 1. So those go away, y is equal to 1. So we have a y-intercept at 0, 1. So let's plot those points. So our vertex is at 1, 2. Our y-intercept is at 0, 1. We have an x-intercept at negative 0.4, so about there, and then 2.4, so about there. So now we just need to find a couple extra points to help us. Actually, just kidding. I need to graph my axis of symmetry. So my axis of symmetry was at x equals 1. There we go. So now we can actually reflect our y-intercept, which is 1 away, to 1 away on the right side. There we go. And then let's just plug in, negative 2 and then reflect it. So y is equal to, I'm going to remind myself what the equation was, negative x squared plus 2x plus 1. Negative x squared plus 2x plus 1. And we're just plugging in negative 2. So y is equal to negative of negative 2 squared plus 2 times negative 2 plus 1. Y is equal to negative 2 squared is 4. The negative of that is negative 4. 2 times negative 2 is negative 4 plus 1. So that'll simplify to negative 7. So let's plot the point negative 2, negative 7. And then it's 1, 2, 3 away from the axis of symmetry, reflected on the other side, 1, 2, 3. And then we have a good idea of what this parabola looks like. We can sketch in that curve. I feel like I didn't draw the right side of that well, huh? Let's do that smoother. All right. So now that we have refreshed our memory on how to find x-intercepts using the quadratic formula, when we can't factor, go ahead and get started on example 2. So for example 2, I want you to do step 1, 2, 3, and 4 on your own. Press pause and then press play when you are ready to check your work. So our equation in example 2 is 2x squared minus 16x plus 33. So a is 2, b is negative 16, and c is 33. So to find the vertex, we're going to take x equals negative b over 2a. So x is equal to the negative of negative 16 over 2 times 2. So x is equal to 16 over 4, or x is 4. So let's plug in 4 and find our y value. So y is equal to 2 times 4 squared minus 16 times 4 plus 33. So 4 squared is 16 times 2 is 32. 16 times 4 is negative 64, and then add 33. So 32 plus 33 would be 65. 65 minus 64 would be 1. So our vertex should be at 4, 1. Step 2, the axis of symmetry is just x equals 4, that x value in our vertex. To find the x-intercepts, we're going to have to use the quadratic formula. So x is equal to negative b, so the negative of negative 16, plus or minus the square root of b squared minus 4ac, all over 2 times a. So x is equal to, the negative of negative 16 is 16, plus or minus the square root of, what is 16 times 16? 256 minus 4 times 2 times 33. So 4 times 2 times 33 is 264, all over 2 times 2, which is 4. So x is equal to 16 plus or minus. These are supposed to be equal signs. Let's fix that. There we go. The square root of 256 minus 264 is negative 8, right? Yeah, all over 4. Well, hey, check it out. We have a negative under a radical. If there's a negative under a square root, what type of solution are we going to have here? Won't they be imaginary? So we have imaginary zeros. So is this parabola actually going to hit the x-axis? No. So we have no real x-intercepts. And that's okay. That totally happens. Step 4, find the y-intercept. All we have to do is plug in 0 for x. So y is equal to 2 times 0 squared minus 16 times 0 plus 33. So y is equal to 0 squared is 0 times 2 is 0 minus 0 plus 33. So y is equal to 33. So we have a y-intercept at 0, 33. Let's plot these points. So we have a vertex at 4, 1. And I just want to point out that A is positive. Because A is positive, we know that we have an upwards facing parabola. So if your parabola's vertex is right here above the x-axis and we're going to face up, it's logical that we're not going to actually hit the x-axis. We're not going to have any real x-intercepts, which matches the math that we did that told us we're not going to have any real x-intercepts. Then the axis of symmetry is at x equals 4. So I'm just going to draw that vertical dashed line through x equals 4. My pen is like being strangely laggy. Sorry. And apparently this line is like moving down. I don't know what's happening right now. Who's in charge here? Okay, let's try this again. Here's my axis of symmetry, equals 4. We don't have any x-intercepts we need to plot, and our y-intercept is at 0, 33. And 0, 33 is like whew, crazy up high somewhere, right? So 0, 33 actually isn't going to fit on our parabola, on our graph, and that's okay. We're not going to bother changing our x-axis, or our y-axis right now. So we need to plug in some values to help us out. So why don't we plug in x equals 1, 2, and 3. So these x values, and then we'll just reflect those points across our axis of symmetry. So I'm just going to remind myself what the equation is. 2x squared negative 16x plus 33. Okay, so now we're going to plug in 1 for x and see what we get for y. So y is equal to 2 times 1 squared minus 16 times 1 plus 33. So y is equal to 2, 1 squared is 1 times 2 is 2, minus 16 plus 33. So y is equal to negative 14 plus 33. So y would be equal to, what is 33 minus 14? 19. And if we plotted 119, again, that's like way up high off our graph, so we don't actually need to worry about plotting that point. Let's do 2. So y is equal to 2 times 2 squared minus 16 times 2 plus 33. So y is equal to 2 squared is 4 times 2 is 8. 16 times 2 is 32. So y is equal to 8 minus 32 plus 33 is 9. So let's plot the point 2, 9. 2, 9 is 2 away from our axis of symmetry, so let's reflect it 2 away on the other side. Then we're going to plug in 3. So y is equal to 2 times 3 squared minus 16 times 3 plus 33. So y is equal to 3 squared is 9. 9 times 2 is 18. 16 times 3 is 48 plus 33. So we're going to take 18 minus 48 plus 33, and we get 3. So we're going to plot the point 3, 3, which is 1 away from the axis of symmetry on the left side. So we're going to reflect it 1 away on the right side. And then make sure when you sketch in your curve to connect these points that you do a U shape. So this looks V-ish, but remember parabolas are always a smooth U shape, and we want to make sure when we graph it, we create a smooth U shape as well. And there we go. We've graphed a more difficult equation that doesn't have real x-intercepts, which is perfectly fine. As you can see, this parabola does not hit the x-axis. All right, well, that's it for this week. You do have a quiz on Friday, and I'll make sure I post that Friday morning so you can get to work on it. I'll talk to you guys next week.